Hi, welcome to this video on circles. Now, you're probably studying circles at school or revising for an important mock or final exam, and you're struggling with circles. Very normal, very hard topic, but generally people don't struggle with the concept. You're familiar with sort of what a circle is, the equation of a circle, probably even the circle theorems you would have met in GCSE. But the exam questions are still very hard. And in this video, we're going to go through all the different types of exam questions, develop sort of the idea and how to attack them, and our goal is, in under sort of an hour's time, be able to get you 100% in any circles question. Now, what I recommend is, before we do any of the questions, have a go yourself, and if you're familiar with the concept of circle, you might want to skip the first bit and move to the first question, as it won't be super useful. But anyway, let's get into it. So the basic idea is as follows. So let's take 2 points. We're going to take, first of all, a point A, B. Secondly, a point X, Y. Now, AB is going to be our center. So let's just sketch this on. Maybe we have AB here. And XY is just going to be some point on our circle, so maybe XY is like this. Now, the definition of a circle is that it is any point that is exactly a radius away from the center. So our restriction on XY, what defines XY, is that it is a distance R away from this point, AB. So then what we can do is we can work out the distance to each point, and to do that we can draw a triangle. So the vertical height, well, that's going to be y minus b. And the horizontal length, well, we're starting at a and we're finishing at x, so it's x minus a. So then if we want to find r, we can just use Pythagoras' theorem. So x minus a squared plus y minus b squared is equal to r squared, where r is our radius and AB is our center. And this is our standard circle formula. What's important to note is that this means our distance from the center, which is equal to our radius, but a lot of people forget this fact. So suppose we were talking about a point inside of the circle. Well, that means the distance from xy to the center would have to be less than r squared. It would have to be less than our radius squared. Its distance is less than the radius if I'm inside the circle. Likewise, if I'm outside the circle, my distance is greater than r squared. So this is inside and this is outside. And we're going to use these facts. Now, the other fact that we should sort of be aware of is a tangent. So if I actually complete my diagram now, I'm going to rub this out like this. And let's complete our diagram. So we've got a circle, maybe it crosses one of the axes, like so. And one of the often sort of exam questions that we receive is a tangent question, where we're told to find a tangent like this. Now, finding straight lines, I need to know either a gradient and a point, or I need to know 2 points. So I've got two options, 2 points, or 1 gradient, 1 point. Usually what we do is we take 2 points and we find 1 gradient. That gives us a point. Now, in the case of a tangent, we're going to be told most likely this point. We then need another fact. We've only got 1 point. Our other fact is going to come from the fact that our tangent is perpendicular to the radius. I have 2 points on my radius. I can find the gradient of my radius. Gradient of a radius is perpendicular to the gradient of a tangent. So that's then how we're going to find the 1 gradient. And we're going to be working on this sort of route. And you'll see this in some example questions that we go through. But this is mainly it. We've got our circle equation, this. Sometimes we're going to need to complete the square to get it in this form, because if I have it in this form, likewise with like y equals mx plus c, it's a standard form and it tells us a lot about our curve. So if it's in this form, AB is our center, r is our radius. So for our first question, it makes sense to look at sort of a standard circles question. This pi, very, very common. And later on, we're going to have a talk about tangents and a problem involving lengths, and then trying to intersect a circle with a line. Very sort of common style of problem. So we just saw that a circle is the form x minus a squared, y minus b squared equals r squared. And then we have that our centre is a, b, and our radius equals r. So square root of this side and taking the positives of these two numbers. So let's have a go at doing it. For this case, we've been told this is a circle. What we're going to do is we're going to try turn it into this form. Now in what we have at the top here, we have x squared and x's, which we don't have down here. We just have an x inside of a square, and likewise for the y's. So it's very clear to us we're going to need to complete the square. So I'm first going to change the order. So I get x squared minus 8x plus y squared minus 2y minus 3 equals 0. Then I'm going to complete the square, so I halve the number in front of x. Half of minus 8 is minus 4, and I subtract that number squared. And likewise for the y, we subtract that number squared. Like so. Next, we simplify this, so we get x minus 4 squared minus 16 plus y minus 1 squared minus 1 minus 3. And we're adding that all over to the other side. We're going to get equals 20. So using this above, we get our radius is the square root of 20. Square root on the right side is r squared, we want r. And AB, well, we take the positives of these numbers. So 4, 1. If they were positive numbers, we'd take the negatives of them. So we get our centre is 4, 1, and our radius is square root of 20. Next, find the values of k for which a line y equals k is a tangent to the circle. Now, it makes sense for us to now draw this. So our centre is 4, 1, so roughly about here. Now, square root of 20 is bigger than 4, and it's obviously bigger than 1. Because it's bigger than 1, I cross at 2 points, and because it's bigger than 4, I cross at 2 points again. So our circle roughly is going to, this I know it's not the best circle, it's more like a potato, but it's more to illustrate what's going on. Now, we're talking about the line y equals k being a tangent. A tangent touches our curve once. In this case, our curve is a circle. So our tangent, y equals k, is going to either be this, or it's going to be this. Where I'll say that this is yk1, this is y equals k2. Now, this is a classic type of question. Whenever you're dealing with a tangent and it involves sort of an unknown letter that they've told you, they might give you like y equals 3x plus k, or blah blah blah. Your strategy is always going to be the same. We're going to intersect our circle with the tangent. So we've got y equals k and x squared plus y squared minus 8x minus 2y minus 3. I'm using this version because then I don't have to expand everything when I intersect them. To intersect two curves, it's like I'm solving simultaneous equations, so I just replace the y's with k's, because that's what it's equal to in here. So you get x squared plus k squared minus 8x minus 2k minus 3 equals 0. Now at this point you might be thinking, well, this is not any simpler. We've still got a really complicated equation. But what's our fact about a tangent? A tangent intersects once. So my number of solutions to this equation is going to be 1. So now we can state our discriminant. B squared minus 4ac equals 0. 1 root. We rearrange it into the proper quadratic form. So quadratic in x. So we group up all the x's together in their sort of proper order, like this. So starting with x squared, x to the 1, then finally the constant term. And now we just do b squared minus 4ac equals 0. So b is minus 8 minus 4 times a times c is equal to 0. This gives us 64 minus, well, it's just going to be minus 4 at the front here. Be careful, biggest way to make a mistake, easiest way to make a mistake is this negative out the front. People often do the negative for the first term but then forget about it for the second ones. So we're going to get minus 4k squared. Minus 4 times minus 2k is plus 8k. Minus 4 times minus 3 is plus 12. Overall giving us minus 4k squared plus 8k plus 76 equals 0. Now we're not going to waste any time here, we're just going to put this in the calculator. We're expecting two values out, hence we've got a quadratic in k. And I get out that k is 1 plus or minus 2 root 5. Remember, we were expecting two values from our graph up here. Okay, the next part, part 3. The points S and T lie on the circumference of the circle. So let's just draw out our circle. We've got, it was something like this. We've got a central point like this. This is, yeah. We then got 2 points S and T. It doesn't matter where we label them. Maybe we label them here and here. M is the midpoint of the chord. So M, S, T. And given a length CM is 2, calculate the length of the chord ST. Well, I'm guessing CM then is our center. Yeah, so they've said center C, so this is going to be C. And we're saying this length here is 2. Now, whenever you're dealing with a length question, you're going to put other lengths onto the graph. So any angles we know about. So first of all, we know this is a perpendicular bisector. That's a circle theorem. So we know an angle from this. And you're just going to look for other common lengths, other common angles, and label them on. Now, the often forgot about length is our radius. The radius is root 20. We've got this is 2. And so we can just do Pythagoras to find this side. So square root of 20 squared, I'm going to call this x, is equal to x squared plus 2 squared. So we get 20 equals x squared plus 4, x squared equals 16, x equals 4. Clearly we're going to take the positive value, it's a length. Lengths are positive. Now we're not quite done, this is only half the length. So ST is length 8. They've not stated any units, so we don't need to state any units. Okay, finally, part 4, find the coordinates of the point where the circle meets the line x minus 2y minus 12. So in other words, we're solving the simultaneous equation x squared plus y squared minus 8x minus 2y minus 3 equals 0. And our second equation is x minus 2y minus 12 equals 0. So to do this, unless there's a simple trick that we can obviously see, we're going to get x on one side or y on one side, and then we're going to try remove it in the other equation. So I'm going to get x on one side in this equation. I'm then going to replace it into here. And then to finish off, all we're doing is we're expanding and simplifying everything that we're left with. So let's quickly do this. So we're going to get 4y squared plus 2y times 12 times 2, so 48y, plus 12 squared, minus, well, that's going to be 16y. Remember, the negative is often forgotten about in the second part of the bracket, so minus 8 times 12, which is 96. Let's see, 8 times 12, yeah, 96, minus 2y minus 3 equals 0. Now, I feel like we're missing a y squared somewhere where there should have been one. And yeah, it was x squared plus y squared, so I should have had a y squared here. Okay, so we get 5y squared. Now combining up all of the y's, we're going to get minus 18y here, plus 48y, so overall plus 30y. Okay, they're both multiples of 5. I'd expect my final number to be a multiple of 5. So we've got 144 minus 96 minus 3, which is 45. So as we sort of expected, it's a multiple of 5. It's just a little check. It doesn't mean it's going to be a multiple of 5. It's just quite likely to be. And if it is, well, it gives us a bit of confidence. So finally we get y plus, well, actually it's going to be plus 3 squared equals 0. So y equals minus 3. And then we can put that back up here to find x, because it's asking for a coordinate. We're always pretty much going to be asked for a coordinate, so we should find a coordinate. So putting minus 3 in here, we get 6. So our coordinate is 6 minus 3. Like that. Not too bad, but pretty tricky and a lot of marks. This is 15 marks, so definitely worth it in a 100-mark paper to be able to do something like this perfectly. So we've got a question here. A circle C with centre at the point 2 minus 1 passes through the point A at 4 minus 5. So we've got some circle. Let's draw this out. 2 minus 1 is our centre, and it passes through the point 4 minus 5, so somewhere about here. Now we know that our circle equation is x minus a squared plus y minus b squared equals r squared, and we're trying to find the equation for our circle. Now a and b are our centre, so straight away this is x minus 2 squared plus y minus 1, so plus 1 squared. Now we need to find r squared. R is an unknown, which means we need one piece of information. One unknown, one piece of information. That piece of information is we pass through this point. Now, what a lot of people like to do is to find a distance between these 2 points. That's our radius. Correct. But what's the point? You've already got a distance calculator. Your distance calculator is on the left here. So let's just put 4 and 5 in. That's going to tell us what r squared is. We're not told to find the radius. We're just told to find r squared. So we get 4 minus 2 squared plus minus 5 plus 1 squared, which is equal to 4 plus 16, which is 20. So r squared equals 20. So our equation of our circle is x minus 2 squared plus y plus 1 squared equals 20. So we've got a radius of square root of 20. Now we're told to find a tangent to the circle at the point A. First of all, it's probably a good idea for us to get a sketch. Given that our radius is root 20 is bigger than 2, it's bigger than 1, we're going to cross all of the axes, potentially something like this, and we've got a tangent at our point A. I'm just going to say A is down here. I know I've previously said it here. I've drawn a circle terribly, so let's just put it here so it doesn't look too disgusting. A tangent here looks like this, which is disgusting. Yeah, anyways, so what we said before is we have one piece of information, that's the point it goes through. The other piece of information is perpendicular to the radius. So we need to find the gradient of our radius. So we've got the point 2 minus 1 and 4 minus 5. The line connecting these 2 points creates our radius. So we're going to calculate the grad, or the gradient, which is y1, which we'll just pick one of the coordinates, minus y2. And then we've just got to match them up. We've matched up the 2 with the minus 1, the 4 with the minus 5. This gives us minus 4 over 2, which is minus 2. So the gradient of the radius is minus 2. So now if you go to our tangent, it's y equals a half x plus c. Negative reciprocal of minus 2 is a half x. Tangent is perpendicular, its gradient is the negative reciprocal. Then we need to put a point in it passes through. That's the point 4 minus 5, which we used earlier. So minus 5 equals a half times 4 plus c. I'm just subbing that point in to find c. That gives me c equals minus 7. So my tangent is y equals half x minus 7. Now we should probably look up, is this what they want it? They want it in this form where they're all integers. So first of all, I'm going to get rid of my fraction. My only fraction is a half. So I'm going to multiply both sides by 2. Like so. And then finally, I'm going to bring everything to one side, giving me minus x plus 2y plus 14 equals 0. And we're done. Now if we go back up, 7 marks, not bad. So in this example, we're told to find an equation of a circle. We're given kind of a lack of information almost. We're given the equation of a tangent, we're given a centre, but that's about it. Now, given that we're trying to find the equation of a circle, we know it's in the form x minus a squared plus y minus b squared equals r squared. So straight away we can deduce that a and b are going to match up with this. We've got our centre, so that's as much as we can sort of fill in to begin with. So we get our circle equation is the same as this, and we're left with one unknown. So if we're left with one unknown, we need one piece of information. Now our other piece of unused information is that this line is a tangent to the circle. But that's not super useful. We saw in the last example that allows us to find, well, in sort of reverse, we could find a gradient of our radius. But how is that going to be useful for finding r? R is a length. So what we really need is we need a point that our curve passes through. And here's the idea. Clearly the only point that could be of interest would be any of the intercepts. But they don't take into account our tangent. And the other key point is where the radius and our tangent meet. And this is what we're going to try to find. So I know this tangent. I can find my radius. And then we're going to find where they meet. That gives me a point. I put that point into here. So let's see this. So we start off by rearranging our tangent. I never understand why they put this in this form. It's not useful at all. So let's first of all rearrange it to give us minus x plus 7. Giving us y is a minus third x plus 7 over 3. Very common mistake would be not dividing by 3 on 7. So yeah, our gradient of our tangent then, or of our radius, sorry, is going to be 3 because it's a negative reciprocal. So we get our radius is 3x plus c. So I've got one unknown here. I need a point or one piece of information. That's a point that it goes through. So minus 2 equals 3 times 3 plus c. That's going to give us c is minus 11. So y equals 3x minus 11. Now at this point, we want to find this red dot, this red coordinate. That's where our two curves intersect. So we're going to intersect these two curves. I'm going to do it over here. So I'm just going to equal them together. So we get 3x minus 11 equals a minus third x plus 7 over 3. So we can add the third x to both sides and add the 11 to both sides. And then we just need to simplify everything. So 3 plus a third, that's 10 over 3. And 11 plus 7 over 3, well, that's 40 over 3. And dividing by 10 over 3, we get x is 4. Finally, we need to find y because we need a coordinate. Otherwise, what do we put in for y here to find r squared? So we're going to put it in the easier equation, which is clearly this one. So we get y equals 3 times 4 minus 11, which is 1. So we know that our circle passes through the point 4, 1, and we just put this in. So 4 minus 3 squared plus 1 plus 2 squared equals r squared. And well, that's 1 plus 9, which is 10. So we get that our equation of our circle is x minus 3 squared plus y plus 2 squared is equal to 10. It didn't ask us to find the radius, it just wants the equation of the circle. That's what we've done by doing this. Now this question is really difficult. So we're told 3 points, and what this is trying to teach us is how to find a circle given 3 points. Now we know our circle is of the form x minus a squared plus y minus b squared equals r squared. We have 1, 2, 3 unknowns. So we require 3 pieces of information, these 3 coordinates. But constructing this circle is going to be quite tricky. Now there's 2 ways of doing it. One could be just straight away subbing in these coordinates. Quite an interesting way in my opinion, but it's going to be pretty messy. But if you want to try that way, be my guest. I think it's be quite interesting, quite fun to do. But yeah, now what they actually want us to do is they want us to find a perpendicular bisector of AB, and that's going to lead us to sort of finding this equation of a circle. So let's first of all do that. So find the equation of the perpendicular bisector of AB. Well, it's perpendicular to AB, so we should find the grad of AB. That's equal to, well, 5 minus 6 divided by 7 minus 0, which is minus 1 over 7. Which means our perpendicular bisector is going to be y equals 7x plus c. So now we need a point that it goes through. It's a bisector. A bisector goes through the midpoint of AB. So we're going to find midpoint. We do that just by finding like our mean. So we add the coordinates together and we divide by 2. Like this, giving us 7 over 2, 11 over 2. Subbing that in, we get 11 over 2 equals 7 over 2 times 7 plus c. That's going to give me 11 over 2 minus 49 over 2 equals c. And to finish off, we can just put this in the calculator, giving me c as minus 19. So y equals 7x minus 19. Now, we did this very fast because it's a very repetitive sort of question. Perpendicular bisector. We find the gradient of that line. We perpendicularize that gradient. We then know that we need a point that the line goes through. It's a bisector, so we find a midpoint. We put the midpoint in. Very repetitive, nice 3 marks. Now, part B says hence or otherwise. So we're going to try to use part A to find the circle that passes through these points. So let's have a go. So first of all, let's draw it out. We're going to have A, which is 0, 6, so something like here. B, which is 7, 5, so it's to the right, but it's just below A. And C, which is 6 minus 2, so it's just to the left of B, and it's below the x-axis. So something like this. Now a circle that connects them all up could be maybe something like that. And what did we actually do in part A? Well, we connected A and B up, and we found a perpendicular bisector. Now it's a circle theorem that our bisector goes through the center. So let's say we have some point C. So my idea for this is to repeat the same but for BC. So we find a perpendicular bisector of BC, and that's going to go for our center. Probably should have picked a better letter than this. Center. But whatever. So let's do that. So let's find a perpendicular bisector for BC. So first of all, we do the grad of BC. That's equal to minus 2 minus 5 over 6 minus 7, which is minus 7 over minus 1 which is 7. That means our perpendicular bisector is y equals a minus 7th x plus c. Now again, we need a point that it passes through, so let's find a midpoint. So 7 plus 6 over 2, 5 plus minus 2 over 2, and that gives us 13 over 2, 3 over 2. So then we can put this into our equation, giving us 3 over 2 equals minus a 7th times 13 over 2 plus c. Adding that to the other side, we get 3 over 2 plus a 7th times 13 over 2. Subbing that in the calculator, this gives me c as 17 over 7. So all in all, we get y equals 7x minus 19 and y equals a minus 7th x plus 17 over 7. Next, we want to find where these two lines meet, because that's our center. Perpendicular bisector goes through the center, which means if we have a line that only meets each other once, because all straight lines do that, where they meet must be the center, because they both go through the center. So we equal them together, giving us 7x minus 19 equals a minus 7th x plus 17 over 7. We hate fractions, so we're going to get rid of this. We're going to multiply both sides by 7, giving us 49x minus 133 equals minus x plus 17. Next, we're going to add x, giving us 50x, and we're going to add 133, giving us 150. That gives us really nicely as x is 3. And subbing into the nicer equation, we get y equals 2. I've put 3 as x here, and that's came out to give us y as 2. Now that's my center, so I know my circle, if I now go and edit this, is 3, 2 here. Now we've got one unknown, r. We need a point that our circle passes through. Well, actually I've got 3 points, so let's put them in. We'll do that on the side here. I'll put the 0, 6 in. That looks the nicest one to put in. So we have minus 3 squared plus 6 minus 2 squared, which is equal to 9 plus 16, which is 25, which is r squared. So we get our circle is x minus 3 squared plus y minus 2 squared equals 25. Now, for you who are interested in this sort of thing and want to try an alternative method, then I'll just briefly explain how to do that. Otherwise, if you're not interested, just skip on to the next question. So let's say I want to do it the other way, where I have x minus a squared plus y minus b squared equals r squared. What we can do is we can sub each of these coordinates in to form some simultaneous equations. So first of all, subbing in 0, 6, like this, we get a squared plus 6 minus b squared equals r squared. And subbing in 7, 5, we get 7 minus a squared plus 5 minus b squared equals r squared. And well, that doesn't really simplify very much. We can expand out, I guess. And finally, we get 6 minus a squared plus minus 2 minus b, and that square is meant to be there, squared is equal to r squared. Now, we obviously want to simplify these simultaneous equations, so what I'm going to do is I'm going to equal the first and the second together, giving me a squared plus 6 minus b squared equals 7 minus a squared plus 5 minus b squared. And likewise, I'm going to do the same for the second, the last one and the top one. So we get a squared plus 6 minus b squared. And again, for some reason, I've taken the square inside of this bracket. not sure why. And that's equal to 6 minus a squared plus minus 2 minus b squared. Now at this point, what you can do is you can expand these out. You're going to notice the a squareds cancel, the b squareds cancel, and all you're going to be left with are b's and a's. You're going to have two linear simultaneous equations which you can solve. You'll find a, you'll find b, and then you sub it into here and you find r. Really nice way of doing it. This is what they meant by the otherwise, for those of you who were interested. So the next one, so we're told a circle has center 0, 10 and radius square root of 20. So straight away I get this information, I'm making an equation. So our circle equation is x minus 0 squared plus y minus 10 squared equals square root of 20 squared, which is 20. And well, simplifying this, we get x squared plus y minus 10 squared equals 20. Okay, we're then told we have a line y equals mx, so let's just put that below, and show that the x coordinate of any point of intersection of L and C satisfies this equation. So if we're finding the intersection, we're just solving these two simultaneous equations. Now we want to find the x coordinate, so I'm going to replace y in one of the equations. Clearly easier to get y on one side in the second equation, so we'll replace y in the first, giving me x squared plus mx minus 10 squared equals 20. Next we can expand this, because clearly if we look at what they've got an expanded form, and what my goal is, I'm going to try and make it look as similar to what they have as quickly as possible. So I'm not going to touch the x squared, I'm going to expand this second bracket. Now we might as well do this by the grid method just to make sure we don't make any simple mistakes. So mx times mx is m squared x squared. We're doing m times m, x times x. Then we get minus 10 mx, minus 10 mx, and finally 100, giving us m squared x squared minus 20 mx plus 100. And we've got an equals 0, so I'm going to subtract 20. Now if we look at this, well, what's similar? This is exactly as it should be, and this is going to simplify to 80, so this is exactly as it should be. The final part is making this look the same as this. So they've taken out a factor of x squared of a bracket. If I take out x squared, and I do indeed get the same thing. So taking x squared out of the first part, keeping the 20mx the same, and adding 100 and minus 20 gives us 80, which is exactly what they want us to show. Not too bad. AII, find the values of m for which the equation in part AI has equal roots. Okay, now bear in mind this is a show that problem, so if you couldn't do the first part, still have a go at the second part, because it's a show that you've been given the equation that is needed for the second part. You're still able to do the second part, and the second part is a completely different topic. Now when they say equal roots, what this is saying is discriminant. It's a massive sort of trigger word that says discriminant test. And we know that b squared minus 4ac equals 0 means equal roots. And you should always state this when you use the discriminant test. Always state what you're doing with it, and state this fact. Now b is minus 20m. We're solving the quadratic in x, not in m. So we have minus 20m squared minus 4 times a, which is 1 plus m squared, times 80, which equals 0. Now expanding, we get 400 m squared, minus 20 squared at 400, m squared, it's just m squared. Minus, and I'm going to first times the 4 by the 80. And then I'm going to expand. And again, remember, people often forget to multiply the second term by a negative. So you get minus 320 minus 320 m squared equals 0. Giving us 80 m squared minus 320 equals 0. Let's add 320. And then let's divide by 80. And finally, let's square root, giving us m equals plus or minus 2. That's interesting, we've got two values. So let's go back up to what they want us to do. Find the values of m. So actually that makes sense. The plural of value here, it sort of reassures us that we needed a plus or minus. We needed two solutions. We should have questioned it if we had just one solution. So that's good, that makes sense. We can be pretty confident on this. Alright, let's have a look at the final part. Now, keep in mind, questions usually build up to a later part. So, if you have a part A, I, and a part A, I, and then it goes into a part B or a part C, bear in mind there may be a link between them parts and the final part. There's not always going to be a link, but sometimes there will, and it's going to help you be more efficient. So, part B, two lines are drawn from the origin. Now, whenever we're talking about lines, we're talking about sort of y equals mx plus c, which are tangents to c. Find the coordinates of the points of contact between the tangent and c. Now, if we think back, what did we do in part AI? Well, we were intersecting a line L, which is y equals mx plus c. Because c is 0, that means it goes through the origin. Remember, c is our y-intercept. If my y-intercept is 0, that's the origin. And then what we did is we found the values of m for which the equation in part AI has equal roots, or in other words, one solution. So what we've done in part AI is we've found these two lines. So we can call line 1 y equals 2x, and line 2 y equals minus 2x. These should be tangents because they only intersect our circle once by sort of construction. Now, what it actually asks us to do, it asks us to then find the coordinates of the points of contact between the tangents and C. Now actually we could intersect, or we could try to intersect our two lines with this, but it'd be a bit of a waste of time because we've already done most of the work in part AI. So what I'm going to do is I'm going to put the value of m back into here and solve the quadratic. So for line 1, we're going to have 1 plus 2 squared, which is 5, minus 20 times 2, which is 40, plus 80 equals 0. And then, well, we can try solve this in the calculator. So 5 minus 40, 80, giving x as 4. Now we're not quite done, we need our y coordinate. We can put that back into here. So y is 8. So 4, 8. And then let's do line 2. So this time we're going to do 1 plus minus 2 squared, which is still 5. Minus 20 times minus 2, which is plus 40x, and 80 stays the same. Then we can try solve this in our calculator. All we're changing is we're changing just to plus 40. And this gives me x as minus 4. And well, subbing it back into here, we get y as 8 again. So we get y equals 4, oh sorry, we get minus 4, 8 as our coordinate. And these are our two coordinates. We should probably detail them somewhere to make it obvious what our answer is to the examiner. Now what's quite interesting is we could have maybe predicted that this would be minus 4, 8. If we were to draw this circle, it's symmetric about the origin. Our center is 0, so our circle lies sort of on that y-axis. The y-axis sort of pierces through the middle, it's a diameter, so it's symmetric about the origin. So it's symmetric about the y-axis, which means we'd kind of expect these two tangents and these two coordinates of intersection given if we had one of the tangents and one of the coordinates. However, I would still sort of suggest doing it this way. It's a lot more clear for whoever's marking it. Try not to cut corners.